and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. We're doing this one question at a time. Here is question 1. A grocery store owner wonders how many customers bring reusable bags to the store. An employee stands at the store entrance for 2 hours and counts the number of people bringing in reusable bags. This type of study is best classified as what? And then we have these different choices, so let's just go through each of them. So it says a census, an experiment, an observational study, and a survey. So just looking at these and thinking about what this person is doing, you could see that he's just observing people who come in and counting them. So this would be considered an observational study, choice number 3. He's not, asking people what they're bringing in. He's not taking a survey. He's not doing any kind of experiment or census. So this is choice number 3. Question number 2. The graph of y equals 2 to the x minus 4 is positive on which interval? So here, if we just take our calculator and plug in this function 2 to the x minus 4 and then hit graph, they want to know where this graph is positive. So just to sketch out what's going on here, it looks something like this. So if we want to know what point this is where the graph is positive and going to infinity. This is where the y values are going to infinity, from this point of x to infinity. So what point of x is that? So let's look. So it's definitely a positive number. So if you look here, it looks like it's at 2. So this is 1 and this is 2. And everything before 2, you'll see the y value is negative. So we know that from 2 to infinity is positive. So this is choice number 2. Question number 3. Tim deposits $300 into a savings account. The annual interest rate is 2.7% and compounds monthly. He uses the equation, and then we have this thing here, a equals 300 times 1 plus 0.027 over 12 raised to the 12t, to determine how much money A he will have after t years. Which equation is equivalent to Tim's equation? So when there's questions like this that come up a lot. So what we want to do is just kind of calculate what's going on inside of this parentheses. So if we have 0.027 divided by 12 and then plus 1, we get 1.00225, and then this is still raised to the 12t. So if you look around, you'll see that choice number 1 looks a lot like this. And really we just want to ask ourselves if, the only difference here is that 12 is separated 12, and then there's another parentheses, and then the t. But you can see that these are going to be equal to each other. So choice 1 is our answer. Question number 4. Which equation is true for all real values of x? So if you see here, we have x to the 4th plus x, and then we're setting it equal to an expression. We want to make sure that one of these is correct. So let's look at the first one. So if we have x to the 4th plus x is equal to, so I'm just rewriting this right now. So now we want to distribute, basically. So we want to do x times x, which gives x to the 4th, x times minus x squared, and we want to keep doing this pattern. And then we're going to do the same thing with the 1. So 1 times x plus 3, 1 times x to the 3rd. And now we can just combine like terms. So we have an x to the 4th. These are going to cancel out. These are going to cancel out. And we're left with x to the 4th plus x. And does that match what we have to the left of the equal sign, x to the 4th plus x? Yeah, so this first answer choice happens to be correct, which is good because it saves us a lot of time. And if you went one by one and checked these, you would see that these would not equal x to the 4th plus x. Question number 5. The solution of x over x plus 3 plus 2 over x minus 4 is equal to 2x plus 27 over x squared minus x minus 12. So the first thing is what? So we want to find the value of x. So the first thing we want to do is factor out this x squared minus x minus 12 using product sum. So using product sum, we get minus 12 minus 1, which will give us negative 4 and 3. So this denominator can be written as x plus 3 times x minus 4. So let me rewrite the equation down here, x plus 3. And now rewriting with this new factor denominator, x plus 3 times x minus 4. So to do fractions like this, we always need a common denominator. And this works out really nicely because whatever is missing from this denominator, we can just multiply to get it to be a common denominator. So x plus 3, so we want to multiply the numerator and denominator by x minus 4 over x minus 4. And then over here, what's missing is x plus 3, so we'll do the same thing on the other side. So now we're going to distribute, so we'll get x squared, x times x is x squared, plus, and then we'll distribute over here, 2 times x plus 3. So that's plus 2x plus 2 times 3 is 6. And then equal to this numerator that they gave us to start with 2x plus 27. So they all have the same denominator now, x plus 3, x minus 4, and because of that we could just kind of drop it. So now next all we have to do is solve for x within this and combine like terms. So this gives us x squared. And we just want to bring everything to one side, so we'll subtract this 2x minus 2x, and we're going to subtract 27. And this will give us x squared minus 4x will give us minus 21 equals 0. And then we're going to do the same thing, product sum. So product is minus 21, sum is negative 4. And if you need more practice with product and sum, I have a bunch of videos on factoring with sample questions, so please check that out. And here we'll get negative 7 and 3. So this can now be rewritten as x plus 3 times x minus 7 is equal to 0. We'll get x equals negative 3 and x equals 7. So before we just circle our answers, negative 3 and 7, notice that this minus 3 we'd have to reject, because if we put in negative 3 for x, this would end up as 0 in the denominator. So we're going to have to reject this because we can't have that. And all we're left with is x equals 7, which is choice number 4. And that's our answer. Question number 6. The cost in dollars of a single ride fare in the New York City subway in the year since 1904 is listed on the table below. So here we have the x values, which is years since 1904, and then we have the fare, so the price. Which equation best models the cost of a single ride fare based on these data? So here we're going to be using the calculator. Before we get into plugging in our data, let's first look at what kind of equations this is going to be. Is it going to be a linear equation, exponential equation? So let's take a look. So there's different ways to do that. I'm going to graph it out so we have a nice picture. So so remember, x represents years since 1904. So I'm going to count by every 10 years up to 100. And then the price is represented by y of each subway ride. And here I'm going to start at 50 cents and then go all the way up to $3. Okay, so now we can actually graph this. So we have, starting at 0, it's at 0.5, so it's about there. Then 49 years later, so about here, it's now 15 cents, so just a little bit higher than that. $111 years later, so we're going off the charts here, it's $2.75, so it's about here. So if we connect our data points, notice this looks like an exponential equation. So now that we know what kind of equation to look for, let's plug in our data points. So we're going to go to Stat, Edit, and I already plugged them in here. So for all the x values in L1, we have 0, 49, 72, 91, 99, 111, and then for the y values, plugged in 0.05, 0.15, 0.5, 1.5, 2, and 2.75. So now we're going to go stat, go to calc, and then go down. Remember finding the exponential equation. So we're going to go down to exponential regression, which is 0. Press enter. Press enter a couple of times. And then we're going to have our regression equation. So this represents y times ab to the x, where a they give us is 0.0375, just rounding, 0.0374, but this is, we're rounding up because next to a 9, times b, which is 1.0392, rounding again because that 1 is next to a 9, raised to the x. And this is choice number 1. So not a hard question as long as you know how to use the calculator and know that this is going to be an exponential regression. Question number 7. Which expression is equivalent to 6x to the 4th plus 4x cubed plus x plus 200 divided by x plus 2? So here in this question we can use synthetic division. So I'm going to set that up. Minus 2, so we're just taking this plus 2 and we're going to do the opposite of that, minus 2. And we're going to take the coefficient of each of these. So we have 6, 4, and then make sure that they're in order. So we have x to the 4th, x to the 3rd. Notice there's no x squared here, so we're just going to put a 0 as a placeholder. And then we have 1, and then we have 200. And now we can do our synthetic division. We're going to bring down the 6 and then multiply it times -2, which gives us -12. Then we're going to add these together. 4 plus -12 will give us -8. And we're just going to keep that pattern going. -8 times -2 will give us 16. So we keep multiplying and then adding. So -8 times -2 is 16. Then 16 plus 0 is 16. 16 times -2 is -32. We end up with a remainder of 262. So this last value is always going to be the remainder. And now we're going to put our answer together. So before we had 6x to the 4th, all these are the leading coefficients of our answer. And we're always going to subtract the previous value of the power. So this was x to the 4th, so our answer will have 6x to the 3rd minus 8x squared. We're just going to go down in order. Plus 16x minus 31. And then don't forget about this remainder. This will be 262 over that original expression we were dividing by, 262 over x plus 2. So our answer is 6x cubed minus 8x squared plus 18x minus 31 plus 262 over x plus 2, which is choice number 4. Question number 8. The solution to the equation 6 times 2 raised to the x plus 4 equals 36 is what? So let's just write that over here. So the first thing I'm going to want to do is divide out this 6. And we get 2x to the 4th is equal to 6. And then it doesn't seem like there's going to be a way out of this without using ln. So to do that, we're just going to use rules. So we're going to bring down this exponent x plus 4. And then ln of 2 is equal to ln of 6. Divide both sides by ln 2. And then get x plus 4 is equal to ln of 6 over ln 2. And then we're going to just bring this 4 to the other side. X is equal to ln of 6 over ln 2 minus 4. Which is choice number 4. Question number 9. The asymptote of graph f of x equals 5 log of x minus x plus 4 is what? So first thing I want to do is go to y equals on the calculator and plug this in. So we have 5. So just to sketch out our graph, you could see what this looks like. There's an asymptote right here at this point. So let's look at what value that might be. So it's going to be a negative value, and it looks like it's at -4. -3 is 0. So this is 1, 2, 3. And then it looks like the errors start at -4. So that means that's going to be where asymptote is. So x is equal to -4. Choice number 2. Question number 10. The probability of having math homework is 1/3. So I'm just going to take some notes on the side here. We have the probability of math is equal to 1/3. And the probability of having English homework is 1/7. So the probability of English is 1/7. Probability of having math or having English homework is 9/21. So probability of math or English is 9/21. What is the probability of having math and having English homework? So we have probability of math and English. We're just going to multiply the probabilities together. So it's going to be P of M times P of E. So when we do this, we'll get 1/3 times 1/7, which is just 1/21. So that's a nice formula to remember. And the answer to this is choice 3. Question 11. The solution set of the equation x minus 1 equals radical 2x plus 6 is what? So let's write this out on the side here. So to get rid of this radical, what we're going to do is do the opposite to both sides, which in this case would be squaring it. So we're going to square this and we're going to square this. So this on the left will give us x minus 1 times x minus 1. And then on the right, it's just going to make the radical disappear, which will be 2x plus 6. So now we can distribute this, or FOIL it, x squared, and this will give us x squared minus 2x plus 1. And we can combine like terms here and bring everything to one side. So we'll bring this over and this over to one side, and we'll get x squared minus 4x, and 1 minus 6 is going to give us minus 5 equals 0. So I'm going to bring this up here so we can factor it using product sum, where the product is minus 5 and the sum is minus 4. This will give us negative 5 and plus 1. So we have x plus 1 times x minus 5. And we'll get x equals negative 1, x equals 5. So before we say these are both our answers, let's first check and make sure they both work out. So let's do a check on the side here. So let's look at the original equation and plug in negative 1. So we have negative 1 minus 1 is equal to 2 times negative 1 plus 6, and then this on the right is all under a radical. Negative 1 minus 1 will give us negative 2. So notice this will give us negative 2 is equal to 2. So that's not going to work out. We're going to have to reject this negative 1. So let's make sure that 5 works out. So we're going to put in 5 here. Minus 1 is equal to 2 times 5 plus 6. This is going to be equal to radical 16, which will give us a correct answer. 4 is equal to 4. So we know that x equals 5 is correct. And when we look at our answer choices, we see that choice 2 is going to be our answer. Question number 12. Given x is greater than 0, the expression 1 over x raised to the minus 2, all raised to the negative 3/4 is equivalent to what? So this looks confusing, but let's do this one step at a time. So I'm just going to rewrite what we have down here. So if we distribute this exponent to the numerator and denominator, let's see what happens. So we have 1 to the negative 3/4 all over x to the negative 2 raised to the negative 3/4. This 1 is going to remain 1. And then down here, we're going to be multiplying, since they're separated by parentheses, we're going to get multiplying the exponents. So this will give us 6 over 4. So x to the 6/4, which can be reduced, right, because they're both divisible by 2. So this will give us x to the 3/2. And then we can rewrite that as radical x raised to the 3rd. You think you might be done, but if you look at the answer choices, there's nothing that looks like that. So let's break this down even further. So in here we have, within this, we can actually break this down. There's an x squared times a radical. There's a radical x squared times a radical x, right? If we were to take the square root of an x squared we'd be left with x on the outside, and then we have this radical x left over. So this question is a little tricky because I feel like there's like multiple right answers of how to write this equation, and you kind of have to keep playing around with it until you get the right answer, which is choice number 2. Question 13. The graph of which function has a period of 3? So just a reminder of what the period is. It is 2 pi divided by the frequency. So if we look at number 1, we have y equals -7 sine of 2 pi over 3x minus 5. So just a reminder of what each part of this trigonometric equation is. This over here is the amplitude. This is the vertical shift. And then this right here, 2 pi over 3, that is the frequency. But they're asking about the period, not the frequency. So to get the period, we're going to do 2 pi divided by the absolute value of the frequency. And they want it to be equal to 3. So if we look at this example, the frequency is 2 pi over 3. So this would be 2 pi over 2 pi over 3, which would then be equal to, based on just dividing fractions, this would become 2 pi times 3 over 2 pi. So just flip this denominator, this fraction in the denominator, and multiply, and then these two cancel out, and then we're left with 3. So the first choice happens to be our answer, choice number 1. And if you try to do 2 pi divided by the other frequencies, they wouldn't work. So if you did 2 pi divided by pi, you would end up with 2, not 3. So that's our answer. Yeah, I go over in more detail. I have a ton of examples on this, on how to find the amplitude, frequency, period, and vertical shift, and even graph trigonometric equations, so please check those videos out. Question 14. Which graph could represent a 4th degree polynomial function with a positive leading coefficient, 2 real zeros and 2 imaginary zeros? So since this is a 4th degree polynomial, we know we're going to have one of the shapes that we have here. So all of these represent some sort of 4th degree polynomial. So that means there's four unknowns to this equation. So other things we also know is that this is positive coefficient. So if it's positive, that means it's going to be facing up like a happy face. So already we can see that we're dealing with numbers 1 and 2 because these are positive endpoints facing up. So we know these two are the only contenders. Notice these numbers 3 and 4 are facing down, so we could just eliminate those. It also says 2 real zeros and 2 imaginary zeros. This can be shown by what hits the x-axis. So if you notice, we only want 2 real zeros. We only want 2 points that hit the x-axis. So that would be here and here, 1, 2. So we know that choice 1 is our answer. Over here, this hits the x-axis 4 times, 1, 2, 3, 4. So that would be 4 real zeros. This only has 2 real zeros. And we can assume that there's 2 imaginary zeros here also. So the choice 1 is our answer. Question 15. Given I is the imaginary unit, which expression is equivalent to 5i times 2x plus 3i minus x times radical -9? Okay, so let me rewrite this over here. We're dealing with imaginary numbers. Okay, so first I'm just gonna start on the left of this expression here, so we can distribute this, and we'll get 10xi plus 15i squared, and then we could deal with this. So we're never allowed to have negative under a radical. So to deal with that, when that happens, we're going to take the square root of this and attach an I to it. So this radical -9 will become 3i. And since it's next to an x, it's going to become 3xi. We can combine like terms, 10xi minus 3xi. That will give us 7xi. And then this I squared is actually equal to -1. So this is going to become -1 times 15, which will give us -15. So just a little reminder about i's. So the imaginary numbers, they have different values. So just a reminder about imaginary numbers is that when they're raised to different powers, they have different values. So I to the 0 is 1, I to the 1 is I squared is -1, and then I to the 3rd is -I. And if you ever forget these, but you know that they represent something, you can also always plug them into your calculator. So you go second I down here, and then whatever number you're looking at, you could plug it in. So I squared is -1, I cubed is -I. So this is really good to remember when answering these kinds of questions. Question 16. What is the focus of the parabola 8 times y plus 2 is equal to x plus 5 squared? So here, let's write this out. So we have 8 times y. So I'm going to want to get y alone. So let's do that. So we have this equation. So this is our parabola, and they want to know what the focus is. So to get the focus, there's a formula for that. The focus, when something is in vertex form, is always equal to h comma k plus 1 over 4a. So how do we apply h, k, and a? How do we apply it to this? So just a reminder what vertex form looks like. This is vertex form, y equals a times x minus h squared plus k. So using this kind of framework, we can look at this and see how this is similar. So I'm just going to, this 8's kind of throwing me off though, right? I'm just going to take out this 8 and I'm going to make it 1/8 times x plus 5 squared minus 2. So that way we can clearly see that a is going to be equal to 1/8. So I'm just going to write out all the different values this is. So you could see that this is a is equal to 1/8. You could see h is equal to -5. And then you could see k on the end here is -2. So now we can use this formula for the focus and plug everything in. So knowing this, we can say the focus is equal to h, -5, and then comma k, which is -2 plus 1 over 4 times a, which is 1/8. And if we compute this a little bit, and we'll get 0. Once we compute this, we'll see we'll get 0. So we're going to get -5, 0, which is choice number 1. Question 17. Given q of x is equal to 2 log of x and r of x is equal to x minus 2 raised to the third power minus 4, what is the solution of q of x equals r of x to the nearest 10th? So the way to do this algebraically would be to set these equal to each other, these two equations equal to each other, and solve for x. But since this is a multiple choice, we can do this the easier way and just plug this into y equals. So now we're going to see where they intersect at this point right here by going to second calc, go down to intersect, and then make sure that we hit both equations. So here's one, we're getting this first curve here, and then you can see it lit up on the second curve, enter, enter, enter again, and then we're going to get the value of x, which is 3.726, and then wanted it to the nearest 10th. So we know that we're just going to round it to 3.7, which is choice number 2. Question 18. The volume of a cardboard box can be modeled by v of x, which is the product of the length, width, and height x. So we want the length, the width, and the height, which they said is x. The length can be represented by L of x, which is 18 minus 2x, and the width can be represented by 18 minus 2x. Then which function represents v of x? We want to multiply these three values together. We want the length times the width times the height. And they said the length is 18 minus 2x. And then for the width, it's also 18 minus 2x. And then the height, they kind of sneak it in there, but it's right here, and height x. So we're going to focus on distributing this, and then we're going to multiply it times the height x. So now we just need to distribute this. So we want to do 18 times 18. And then we have this entire thing times x. And then we're just going to distribute the x to each part of this equation. So we can clean this up a bit. I'm going to put it in order, and we can also combine like terms here. So to put it in order, I mean by power order. So we want to start with the highest power. So x to the third is the highest power, so we have 4x to the third. And then notice we can combine like terms here. Negative 36 minus 36 is going to give us minus 72x squared. And then we're left with this 324x. So now all we need to do is go and look at our answer choices. Choice number 2 is our answer. Question 19. The expression 8 raised to the x over 2 times 8 raised to the x over 3 is equivalent to what? So what's nice about this question is notice we have the same base. So when we have the same base, all we have to do is add the exponents together. So we want to do 8 raised to x over 2 plus x over 3. And then we got to figure out what this is. So just a reminder of when we're adding fractions. And when we're adding fractions together, they need to have the same denominator. So we're going to multiply the numerator down by the same thing, 3 over 3. And then on this side, 2 over 2. And this is going to give us 8 to the 3x over 6 plus 2x over 6. So now they have this common denominator of 6. And this is going to give us 8 raised to the 5x over 6. You can see that 8 raised to the 5x over 6 does not show up in any of the answer choices. But what does show up is this written in a different way. So if we rewrite this, what we're going to end up with is 8. And then since the 6 is in the denominator, that's actually going to go over here. And then this 5x is really what 8 is being raised to. So this is just rational exponent rules. Exponents are in fraction form, they end up forming this. So for example, a little easier, something easier to look at is 4 raised to the 1/2 is equal to radical 4. 4 raised to the 1/4 looks something like this. And the pattern continues. So this is going to be our answer. And I have more questions if you want to check that out and do more examples. Our choice here is choice number 1. Question 20. If theta is an angle in standard position whose terminal side passes through the point -3, -4, which statement is true? And you'll notice we're looking at what's positive and what's negative here. Let's draw out a coordinate plane. And then look at the point that they give us. So the terminal side passes through the point -3, -4. So that's going to end up over here, right? -3. So it's going to look something like this, -3, -4. So we could figure out, and this is where angle theta is that they're talking about. We could do this the long way and look at this right triangle and look at tan of theta and secant of theta and realize what's positive and what's negative based on this angle. Or we could remember the trick all students take calculus, ASTC, where all trig functions are positive within the first quadrant. So just a reminder of what the quadrant numbers are. 1, 2, 3, 4. All are positive here. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. We know that secant of theta, remember secant of theta is equal to 1 over cosine of theta. If we're looking at something in quadrant 3, we know that secant of theta is going to be negative. And we know that tan of theta is going to be positive because it's in that third quadrant. So we know this is going to be positive. So we're looking for just that this answer. Secant of theta will be less than 0 and tan of theta will be greater than 0. So it looks like this is going to be choice number 4. Secant of theta is negative and tan of theta is positive. Choice number 4. And if you wanted to do this the long way, you could actually count out the units, figure out what would be positive and negative. So if this is -3, this is -4, this is 5, right? So this was just the coordinates they give us. This is -3, this is -4, and then this is just a Pythagorean triple. 3 squared plus 4 squared will end up giving us 25 or 5 for the hypotenuse. And if you did secant of theta, that would be the secant of theta, so cosine of theta is the adjacent over the hypotenuse. So that means the secant of theta is going to be the opposite of that. It's going to be the hypotenuse over the adjacent. So hypotenuse over adjacent, according to this angle, would be 5 hypotenuse over the adjacent -3. So we see that it's going to be negative. And for tan of theta, that's equal to the opposite over adjacent. So that's opposite, -4 over the adjacent, -3. -4 divided by -3 will just give us a positive 4/3 because we got two negatives. So that's a positive, which is choice number 4. Question 21. What is the value of y for the system shown below? So you'll see that we have 3 systems of equations and then 3 unknowns. They only need to know what the value of y is here. So to start off, I'm just going to label each of these equations 1, 2, and 3. So we're going to have the goal of canceling out one of the variables. So just looking at this, I think the easiest variable to cancel out, it would be z, because there's no coefficient in front of it over here. This is going to be like our temporary goal to start with. And you'll see why I'm writing this out in a little bit. So if our goal is canceling out z, let's now choose 2 equations to add together to cancel out z. So I'm going to start with equations 2 and 3 because that looks really easy. So I'm going to rewrite them down here. So equation number 2 is, and equation 3. So to cancel these out, notice canceling out z, we just need to multiply this entire top equation by 4. That means we're going to distribute 4 throughout this entire equation. So when we do that, we'll get 8x plus 12y minus 4z equals -12. And then this bottom equation, equation 3, is just going to stay the same. And we're going to bring it over. And then when we add these 2 equations together, we're going to get 14x plus 11y, and then these z's, -4z plus +4z, this is going to cancel out, and then over here we have -9. So this is good, we canceled out z, but it doesn't seem like we're any closer to getting the value for y. So what we need to do is do this step again with picking out 2 equations up here with the same goal, canceling out z. So now I'm going to choose equations 1 and 2. So 1 is 3x plus, and 2. So to cancel out for z, what we're going to do is multiply this entire second equation by -5. So now we're going to keep the top equation the same. And then this bottom equation, we're going to distribute -5 times each of these terms. So add these together, and we're going to get 7x minus 11y, and then these -5z plus +5z, that's going to cancel out, and then on the right we'll have -12. Okay, so now, since we did this 2 times, notice we have these 2 equations without any z's. So now we just have x's and y's. So we're going to bring these 2 equations together and see what happens. So let's stack these 2 equations. 14x plus 11y equals -9. And then our other equation, 7x minus 11y equals -12. So if we were to add these equations together, you could see that these y's are going to cancel out. 11y plus minus 11y, that's going to cancel out. And the rest of the equation, well, this is a negative. Sorry, the -7x. So over here, this is a negative. 14 plus -7x will give us 7x. These canceled out like we just said. And then on the right, we have -21. And we get x is equal to -3. Remember, they're looking for y though. So we found x. So now let's plug in this x is equal to -3 into one of our equations that we've just found. So if I go to 14 and plug in -3 for x, which we just found, plus 11y equals -9, we could now solve this for y, which is what they're looking for. And here we get y is equal to 3, which is our final answer that we're looking for, choice number 3. Question 22. The number of employees who work nights and weekends at a department store is summarized in the table below. Let n represent the event work nights. So I'm just going to say this is n, work nights, and let w represent the event works weekends. Works weekends is over here, so this is w. Based on the table, are n and w independent events? The key to remember here is that events n and w are independent if the probability of n and w is equal to the probability of n times the probability of w. So there's a formula to remember for this, which is right here, really. It's just we have to remember what it means. Events n and w are independent only if this is true. So we need to see if this holds true. And then we can take a look at which answer makes sense from here. So let's first find the probability of working nights. So working nights is right here, and you'll see that this adds up to 20. And then if you're looking at this whole thing, this adds up to 100, and then this whole total is equal to 120. So if we're just looking for the probability of working nights, which is represented by n, work nights, you could see that's going to be 20 over the total 120. And then we're going to find the probability of working weekends, which is represented by w. So working weekends, you could see is along this way is going to be 48. So people who work weekends is 48 out of the total 120. And all we need to do is multiply this together. So let's see if we can reduce this. And we'll get 1 over 15. So that means everything on this side, p of n times p of it, is equal to 1 over 15. So now we need to see what p of n and w is. So that means we're looking for the overlap of people that work nights and work weekends. So work nights and work weekends. So that would be this number right here, 8, out of the total 120. So we need to see, does that reduce to 1 over 15? So let's plug that in, 8 divided by 120, and reduced, and that it does work out. So 1/15th is equal to 1/15th. So that means these events are independent because these are equal to each other. So if we go back to our question, it says, are n and w independent events? And the answer is yes, because this works out. So this is choice number 1. Question 23. Which expression is equivalent to x to the 8th minus y to the 8th? So here we're going to be factoring using dots, the difference of two squares. So this is nice, and we know we can do this because there's a minus sign between these two variables, and then both are raised to an even power. So what that means is we can do something called a double bubble with a plus sign and a minus sign. We're going to keep the same order of x and y, and then we're just going to half the exponent values. So they're 8, so 8 divided by 2 will give us 4. So it'll be x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. And notice we can actually do dots one more time here. So this x to the 4th plus y to the 4th is going to remain the same. And then we're going to do difference of two squares again. So we'll have that double bubble, plus and a minus sign. And then for the exponent, again, just split it in half. So this is going to be now raised to the second power. And notice again, we can do dots one more time right here. So we're doing dots. Okay, so we have x to the fourth plus y to the fourth, x squared plus y squared, and then I'm pretty sure this is our last one. We have x plus y times x minus y. And the power 2 divided by 2 would just be 1, so we could just leave it like this. So we have this as our answer, x to the fourth plus y to the fourth times x squared plus y squared times x plus y times x minus y, which you could see is choice number 3. So we got to do dots 3 times. Question 24. A research assistant receives a first-year salary of $90,000 and a 2% annual raise throughout the first 10 years of employment. In total, how much money will be earned over the first 10 years to the nearest dollar? So for this question, let's, before we write out a formula and fill it in, let's look at what we're actually doing here. So we're starting at $90,000 and then there's an annual raise of 2%. And they want to know the first 10 years, how much in total they'll be making. So that means the first year, this person is going to be making $90,000. And then year 2, it's going to be making 2% more of that. So it would be $90,000. So that would be 90,000 times 1.02, which gives us 91,800. So we're doing 1.02 because our raise rate is 0.02%, but we still are including that 90,000. So if you did 90,000 times 0.02, this $1,800 is just how much more you're going to be making from what you made the last year. So we're going to do that every year. So then in the third year, we'd be doing what we made the last year times 1.02, 91,800 times 1.02. And then in the third year, this person would be making 93,636. And this question is asking us to go all the way down until we get to the 10th year. And then whatever that value is, they want to add all of these values together. So I could go one by one and do that slowly. Or I could use, there's a formula to kind of speed this up. It's a geometric series formula. S sub n equals a sub 1 minus a sub 1 r to the n, all over 1 minus r. So I'm just going to point out what each of these represent. And this right here, a sub 1, is going to be equal to the initial amount, that first amount, which we know is $90,000. Our rate we've been using that we're multiplying by is that 1.02 annual rate, going up each year by 1.02%. And then n is just the number of years. So they want to know how much money this person's going to make summed all together in the first 10 years. So this is going to be equal to 10. So then we have all our information and we can just plug this in. So this is 90,000, and then there's another a sub 1 here. And now for the rate, 1.02 raised to the 10, all over 1 minus r, which we said is 1.02. And now all we have to do is plug this into the calculator. So I'm going to do this step by step, focusing on the numerator here. And you'll see that we get 985,474 and 89 cents. They want us to the nearest dollar, so we're just going to round this up, $985,000 and 475, which is choice number 4. So this is the end of part 1. Look out for part 2 coming out soon. Please let me know if you have any questions, and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!